Hi, in this video I'm going to show our new steel member calculator and in particular our built-up steel member functionality. So I'm going to create a new calculation. I'm actually going to start with the steel member here. If I do this, and it's going to load. So this is our new calculator for steel member design. You can see here by default we've got just a W shape, and here you can enter your different loads. So maybe we'll enter 10 kilonewton meters, and we can have a 5 kilonewton shear loads and maybe a 5 kilonewton compression load. And you can see immediately we do all the checks. This is really low loads, but we do that including the interaction check for compression and bending and the shear load as well. So right now we support all the standard W shapes here, and you can see that. Now, that's one way to do it. Now, the other thing that gets really cool, though, is if I do a new calculation and I create a custom cross-section, let's just do a generic one. I can now create a custom I section or a monosymmetric I section, and it's going to run all the calculations for it. So if I do, say, this section, maybe I've got a really deep girder or something like that. So maybe I'll make that 1400 millimeters deep, and breadth is going to be 600. Actually, let's make it 400. I don't know. Okay, so we've got this and 15 millimeter, 15 millimeter. Let's make it 25 millimeter, 1-inch plates all around. Okay, so now if I come back to my steel member and I say, would you like to link a custom section? Yes, I can come here and link it. Let's see, here we go. And you'll see I've got my picture here of my cross section, and all my calculations are run properly. And that includes, we calculate all the section properties, moment of inertia, torsional properties as well. It's all calculated here. So I can do this. I can also set, if I want, my compression and bending interaction properties. So especially for the U1 moment magnifier, sometimes people like to set that manually, especially if you've got a unbraced frame. Otherwise, you can also set your omega 1 value here. So that's for a doubly symmetric section. I can also now go, if I want, and create a monosymmetric I section. So let's make this one a little bit less deep. Let's say 600. And I can see my web thickness is still at 25. Let's make it at 15. And maybe you can see I've got a 150 flange on top and 200 flange at the bottom. If I come back here, you'll see, again, I've got the same cross section. If I can zoom in, you can see it's a little small drawing, but you can see that. And we do all the calculations again for monosymmetric I sections, considering, the special formulas from the code, all that fun stuff. That's both for compression and for bending and for lateral torsional buckling. The one thing, and you see a note here, right now we're taking the flange slenderness as the maximum slenderness between the top and bottom flange slenderness. So if you've got a class 4 web, we might be a little on the conservative side, but that's a small effect, and I expect we'll be updating that shortly. Otherwise, I can set my yield strength, I can set my total length, my unbraced length for bending. By default, we've got this at 1.2 L, and if you click on this, you'll see a bit of an explanation. That's just a default for the code, assuming that you've got a destabilizing load. So it's applied towards the shear center, i.e. like if you've got a beam, the load's on top pointing down. And we've also got the omega 2 value, the coefficient for increased moment. So I'll stop here. I hope this is helpful. We've got a lot more opportunities coming in here, like other section types that you'll be able to link in. Send us a message if you've got thoughts, if you've got suggestions of other section types you want to see in here. Otherwise, thank you, and look forward to hearing your comments on this feature. Thank you. Bye-bye.